with that in mind, what we're going to do is we're going to do this lab. We've already done portions of it before. We are going to set up the VLANs. We're going to put these different ports in the correct VLANs so that these devices will be able to communicate with other devices that are within the same VLAN. We're going to set up that for each one of these colored groups. We're going to then set up this switch, basically with all the same commands. We're going to create the VLAN 10, put the ports fast 0, 1 through 8 into VLAN 10. VLAN 20, ports 9 through 16 are going into VLAN 20, and then we're going to do VLAN 30, and ports 17 through 24 are going into VLAN 30, just like we did on this switch right here. We're then going to create a trunk. We're going to make this port GIG01 a trunk. We're going to go up to our router, and we're going to create the sub-interfaces that we need so that we'll be able to route between the VLANs. We're going to be able to route between the VLANs. All the commands are actually right there for that. So we're going to make a trunk here. We're going to make this receiver of the trunk. And the trunking protocol we're going to use is what? 802.1q. That's why the command encapsulation .1q tells the trunking protocol is going to be 802.1q. We're also going to configure a trunk going across here. Wow, a trunk here and a trunk here. And when we create the trunk, remember that the trunk is going to carry the traffic for multiple VLANs. So we're going to create a trunk here on both sides. Once we've done that, traffic will actually flow from this green PC, this VLAN 10 PC, up here, across the trunk, and directly up, either up to the router or over to the PC that it's communicating with in the same VLAN. Same thing will happen with the VLAN 20. This PC will be able to directly communicate with these PCs because it's part of the same VLAN. It's as if this cable is plugged into this switch, except it's actually plugged into this switch way over here. And so this is how you set up a campus-wide VLAN, where you've got maybe the marketing VLAN or the IT VLAN, and you've got 8 different buildings. It's possible that you could set up PCs in each of the buildings so that they're able to communicate with one another. That would be called a end-to-end VLAN, which is not really a desirable necessarily or a common configuration, but it certainly is possible. So what we want to do is, and then we're going to set up the route, the default route out on our router so that all of our traffic from within this network can get out to the internet. At a later time, we're going to learn how to do network address translation so that we can actually get these PCs that have 172.16 addresses, which are private addresses. Those, as you know, cannot go out onto the internet. The private range, the 10 range, the 172.16 through 172.31, and the 192.168, those 3 sets of ranges are not able to be transmitted out to an ISP. The ISP will block that. Those are not going to be used out on the internet. Those are designed for internal use only. And then we use network address translation at our router so that we can use a public address to connect. And I'll show you exactly how all that works next week. So the first thing I want to do, let's go to this switch. We're also going to set up our DHCP on our router. So I'm going to do a quick run through on this. We're going to do enable. I'm going to call this config T. Host is switch 1. Okay, and I want to put a password on here. Enable password is capital Cisco. And then I'm going to do an enable secret. And what's the difference? That's right. A shoulder server is not going to be able to see that because when you do a do show run, that password is already encrypted right here in the interface. It's actually an MD5 hash. Technically not encryption, but for the purposes of the discussion, we'll call it that. Then we have, and so, but this one is still visible. So if we want to set up our console connection, we can say line con 0. We can put a password on it of Cisco. We can put a login command to require login. We can then say logging synchronous. And then we can do it our exec dash timeout. And we'll do 0, 0, so we never time out. And those are very simple commands to put some security on our console port to prevent somebody from just walking up with a laptop and plugging into it and having full access. We're going to do a line VTY to configure, line VTY 0 through 15. We're going to configure all of our telnet ports, and we are going to configure them with the password of Cisco, the required login. We're going to do the logging synchronous and the exec timeout. So we're going to use our up arrows when necessary to really speed the configuration of these devices because we don't want to have to retype everything all the time. So now our console port's configured, our line VTY is configured. We have a password on the console port. Let's do this, excuse me, on the enable mode. Let's do a do show run. But look at that, I can still see that password. I can still see that password in this one and this one. But what can we do to encrypt all the current passwords and all future passwords? Service password encryption. Remember that command? So we're going to do the service password encryption. And then we're going to go and while I'm thinking about it, I'm going to create the VLANs. VLAN 10, name, marketing. VLAN 20, name, accounting. VLAN 30, name, classroom. Okay. So now we have those set up. The VLANs are there. I want to assign the ports. Here, down here is showing us ports fast 0/1 through 8. We want to put all those into the marketing VLAN. And how can I do all those ports at one time? Interface range. Remember that command? Fast 0/1 space 8. And we'll say switch port, access, VLAN 10. Okay, so essentially we did that command and that command. Now I want to do interface range fast 0/9 through 16, and we'll say switch port, access, VLAN 20. And then finally interface range fast 0/17 through 24. Oops. Got an extra space right there. And then we'll just bring the up arrow to put that into VLAN 30. Okay, so if we want to verify that, verify what our configuration of our VLANs is, we can do a do show VLAN brief. And that's going to list our VLANs. Let me just stretch this out a little bit so it looks nice and clean. All right, so we got, and I'm going to put an extra space in. I'm going to make a VLAN 5. And I'm call that name extra space. I'm also going to create a VLAN 99, name parking lot. And VLAN 999, name native. Or you can spell it that way if we want. We can spell it the odd way. All right, so let's do a do show VLAN brief. There's all of our ports. So we have VLAN 10. And so we still have VLAN 1. It's got a couple of those leftover ports, gig 1 and 2. We've got VLAN 10, and these ports are assigned to VLAN 10. In VLAN 20, we've got these 8 ports, and in VLAN 30, we have these 8 ports. Cool. We also have a parking lot VLAN, so if there were particular ports we weren't going to use, we could put those into the parking lot for security purposes. They would not be able to connect to any other devices. We can also use the native VLAN in the future to set up the native VLAN on our trunking interfaces. Finally, we've got gig 01 and gig 02. Gig 01 is going to be a trunk going up to the router. Gig 02 is going to be a trunk going over to switch 2. So I want to go into interface range, that gig 0/1 and 2, and say switch port, mode, trunk. Now, later we can set up the native VLAN, and we will do so. But for right now, we'll just leave it at the default, which will be native VLAN 1. So let's do a do show interface trunk and just see if any of that has taken place. Look at that. We've got gig 02 is now trunking. That's the link going over here. Why isn't this one trunking? The router port is not turned on, so this link is not up. As soon as that link comes up, it will be trunking because we have configured it to trunk. We can also do a switch port, no negotiate, so that it will not be capable of negotiating an access port configuration on there for security purposes. All right, looks like we're good there. So while we're comfortable doing the switch, let's go over to, what else we ought to do here? Do, copy, run, start. Let's save our configuration. Let's go back over to switch 2 over here, which we haven't named yet, but let's call it switch 2. And I've just named it actually, so I'll save that. What the heck? All right, so we just did it. It's named switch 2. You can see we're already in privileged mode and config. So let's go over here. We're going to do exactly the same thing on this switch that we just did on the other one. So one thing we could do, if we wanted to be really tricky, watch this. Rather than typing all that, we could, since all the configuration is the same, I could do a do show run. See all that? All those VLANs right there is assigned. Everything's cool. I'm going to grab all of this. Watch this. This is cool. I'm going to copy that because we're in a packet trace. We have to click copy. You do Control C when you're in a putty window. It'll work fine. I can just paste that right here. And that, now let's do a do show interface trunk. Look at that. Gig 02 is trunking. Let's do a do show VLAN. Now, one thing with this approach is those VLANs have not been named because the name command was not in the config. So let's just do VLAN 10, name, marketing, VLAN 20, name, accounting, VLAN 30, name, classroom, VLAN 5, name, extra space, VLAN 99, name, a parking lot, and VLAN 999, name, native. All right, so we now have all the VLANs. If we do a do show VLAN brief again, you'll see we have all the VLANs. They are properly named. The ports are in the appropriate VLAN. God, that was quick and easy, wasn't it? That is such a time saver if you have a text file that has that. You could also just take that configuration that we just did. We could open up a notepad session. We could go in here and just paste it all in there and say, you know what, I want some of these other ports. I want this one to be in port 20. We could just edit that right there and paste that whole thing in there. One thing maybe I didn't get because I pasted everything I had captured. If I go to this switch and I say do show run, okay, I did have the service password encryption. Okay, so everything is now, no, I need to turn on service password encryption. Look at that. So let's do a service password dash encryption and encrypt everything. It was already encrypted because when we pasted it in there, it was already encrypted. All right, this switch is now complete. These ports are attached to the correct VLANs. We have the line VTY, the console port security, and enable mode password. The trunk is set up. Let's go up to the router, and we're going to do this one. It'll be just as easy. We'll say no. We'll say enable, config T, host name, ROAS 1. Okay, so now we're just going to do, now, I don't want to type all that stuff again. I have my text file, all this configuration that is right here. Okay, I'm going to take out all the stuff I don't need, which is all the interfaces that are on the switch. I am going to put that in there though. Look at that. So we can put our enable secret, our passwords, all that on there. We just copy that to save us a little bit of time. We go back into our router and we'll just paste that in there. So that line DTY and the console port is already configured. Does that make sense? Okay. I'm also going to do the service and then the password dash encryption because I want to encrypt everything that's moving forward from right now. Now we just need to set up interface gig 01 and a default route out to the internet and our serial port. So we'll say interface gig 0/1, IP no shut, because we want to turn that one on. I'm going to go to interface 0000. I'm going to do a no shut on it. I'm going to put a clock rate on it of 1 million. Now, if I wasn't sure if I needed a clock rate, what's the command to see if the controller is connected to a DCE cable? Do show controller, right? 0000. We look on line 3. We see it says DCE. It's connected to a V.35 connector. The clock rate is shown. Because it's got DCE, it requires the clock rate. Data communications equipment requires a clock rate. All right, so let's put an IP address. It's going to be 71.223.142.250.255.255.0. No shut. I think it's on already. Do ping 71.223.142.250, and we're able to ping our ISP's interface right over here. See that? We just pinged the other side. Cool. We have tested that connectivity. Let's go back to interface gig 01. We're going to actually do an gig 01.10, right? Because we want to set up the trunking interface. And so we're going to use the encapsulation .1Q10. IP address on that interface. If we look down on our diagram, we're using 172.16.10. And it's pretty common that you're going to use the very first address, so we'll use 172.16.10.1. And we got a 24-bit mask, so 255, 255, 255, and guess what? Those are the 3 commands that we needed to do that. If I bring this command up, I can just change the interface to gig 01.20. Bringing this up, change the .1 encapsulation command to 20. And change the IP address on that interface to 20. Now I'm going to do 30. Hit the up arrow. I'm going to do 30. 1, 2, 3. And we'll change the subnet IP address to 30. Okay, so just for testing, let's do a do ping 172.16.10.6. We're pinging the VLAN connection from our router down to here, and we're not getting an answer. Oh, I don't have a 6, sorry. So what we're going to do instead is we're going to ping 9. Hopefully that one's going to give us an affirmative response, and it did. Let's ping 20. So we're now able to ping from the router down to this VLAN. We're able to ping from the router down to this VLAN, and finally we're going to do 30. And we're able to ping from the router down to this PC right here. So, and you can see that the very first ping was missed because ARP was taking place, and then we had 4 successes. If we do the same command again, we should get 100%, and we do. Awesome. All right, let's start off with a default route out to the internet. We want to make sure that anyone from any of these VLANs is able to get out to the internet, to 8888, to Google server. And to create that default route, we have to put the IP route quad 0, just like we've done before, and the next hop. So if you're on this, if the traffic is coming through this router, what's the next hop? It's this interface right here at the ISP. So it's going to be 71.223.142.251. Now we can also save a little bit of time. If I do a do show IP route right now, you'll see that I have a gateway of last resort. That means, hey, if nothing else works, the last resort is to send it to this machine right here for any network. So looking in our routing table, I see we've got all the routes to the local networks. We have a static route at the bottom. That's our gateway of last resort. Any network, any subnet mask, it's static, so the administrative distance is 1. And we're going out this interface. We're going to the next hop. So as the router is trying to route to Google, it's going to look in the routing table and say, I don't have one for Google, but I do have a default route. Let me send it to 71. And then it's going to say, what interface is 71? It's going to go up to the top and start again until it finds the 71 interface. To speed that process, we can actually just also add an entry right here, serial 000. And now when I do a do show IP route, look at this. Check this out. Where previously it did not show the interface right here, now when I do that, look, it's going to say, oh, send it to the next hop. And by the way, you can just send it right out, serial 000. It doesn't have to parse this routing table twice. Awesome. So now from our PC right here that we've previously configured with an IP address, we can verify that with an IP config. And we see that we do have the address of 9. We do have a default gateway pre-configured. Let's ping 8888. And we are successful. Look at that. Amazing. It's like magic, actually. I mean, truly, when you think about it. But what about this PC right here? This PC, right now, it's got a PIPA address. Let's just see. Can we ping out with that one? Ping 8888. No. Why not? Well, because if we do an IP config here, we'll see, oh, I've got a PIPA address. And surprisingly, I've got a default gateway address. It must be remembering that from the past. So I'm just going to reset that. I don't know how I could remember that from maybe from the other day. Okay, so now there's no default gateway. It's completely reset. We go back to our command prompt. We'll see that we have no default gateway. And when we try to ping, we do a trace route. This guy doesn't have a trace route. Trace RT is the command on a Windows machine. This PC has no idea how to get to 8888. The only network it knows about is the 169.254, and so it really can't communicate with anyone. That's really the truth behind a PIPA, automatic private IP addressing. As well, it's a concept that maybe would work pretty well. In practice, it's not real practical. So what we need to do is we need to get a proper address on these other PCs. This PC here says DHCP assigned. This PC here says DHCP assigned. This PC here says DHCP assigned. These are all DHCP assigned over here. So we want to make sure that we are able to get addresses assigned to these. And the way we're going to do that is with what? DHCP, right? Let's go back up to our router. Let's set up DHCP. So first off, we don't want to use the addresses 1 through 100. We're going to start with 101. So when we go to config, we're going to do IP DHCP excluded address 172.16.10.1 through 172.16.10.100. And we're going to do that for each range. So I'm just going to change this to 20, change that to 20, and we're going to do the same thing. Rather than retyping the whole command, we're just going to use our tools, and we're going to use the up arrow to bring back those commands, edit them, and put that save. So we have reserved, essentially, or excluded the address 10.1 through 10.100. So if we are able to set up a DHCP pool, the first address that we're going to give out would be the 101 address, correct? So let's do that. IP DHCP pool. If you remember, this is how we create the pool. And we have to give it a name right here. See where it says pool name? So I'm going to call the first one the 10 pool. And if we had the parking lot and we wanted to assign addresses to all the machines in the parking lot, we could call it the dead pool, because the parking lot machines are not going to be used. Bad joke, sorry. All right, so let's create the pool. First thing we got to do is we say, okay, the network for the 10 pool is going to be the 172.16.10.0. The mask on it is 255, 255, 255, 0. And the default router that all the machines, look over here, all the machines in this green box, green circle, their router is this one, right? What's the interface they're going to connect to get out? 172.16.10.1, right? We set that 172.16.10.1 right here. We set that up for VLAN 10. So we'll just put a 172.16.10.1 and we're done. Let's go back over to this PC. By the miracle of modern science, he's already got an address. Look at that. He already got the address because he continually was attempting to get a new address. And he now has that new address. Let's go down to the router and let's set up, what pool should we do next? IP, no, we're not using one, right? Pool 20 pool for VLAN 20. Now the beauty of this is we can just bring this up, change that to 20, and change the network to 20. So we don't have to retype all this stuff. We're now set up for 20, and watch this. I would expect to see that change in a moment, but I don't want to spend time watching it. So what we'll do, okay, I don't want to wait. There you go. He's got his address right now. Let's see if he can ping Google. Ping 8888. Look at that. Wow, you guys are mastering this stuff. We're learning to configure this stuff. Now, let's do the last one. We just hit the up arrow 3 times. 1, 2, 3. Change the pool number to 30. Hit the up arrow 3 times. 1, 2, 3. Change the router to 30.1. And up arrow 3 times and change the subnet to 30. Okay. And so we would now expect that over here, this PC is going to get an address in a moment. To speed the process up, I'm just going to do that. Tell it to do, what's the process called for DHCP? DORA, right? Discover, what is it, Dale?
Discover, offer, request,
and acknowledge, right? Okay, so can this PC now ping out to the internet? What do you think? He's got an IP address. He's got a default gateway. Of course, he can ping out to the internet. We'll do a ping 8888. All right, so there's cool. He can. Now, finally, what about these guys over here? Do you think that they're able to ping to the internet? Do you think that they are able to ping to the internet?
Yes. No, not if you haven't configured it.
yeah, you gotta configure it first.
Let's do a ping to the internet. All right. We're good on that. I'm going to stop the meeting right now.